Hello there, and welcome back to the Sleep Science. You arrive gently at the idea of light, not as a number or a formula yet, but as a feeling, something that reaches you every morning without asking permission. You picture it spilling through a window, touching the wall before you've fully decided to wake up, warming dust motes that drift lazily in the air. Light feels instant in everyday life, like a polite guest who always arrives early and never makes a sound. And as you settle into this thought, you realize how natural it is to assume that light has no travel time at all, that it simply appears wherever it's needed. After all, when you flip a switch, the room obeys immediately. No waiting, no buffering wheel, no awkward pause. You probably won't survive this with your eyes open. You begin by letting go of speed entirely, on just for a moment, and instead noticing what light does. It reveals edges, colors, motion. It tells you where you are without speaking. A mainstream scientific fact drifts in softly here. Light is a form of electromagnetic radiation, carrying energy through space as oscillating electric and magnetic fields. That sentence sounds heavy, but the experience isn't. It's simply the reason you can see the outline of your hand, the curve of a shadow, the glow of a screen dimmed for nighttime comfort. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. You can almost smile at the idea of tapping a button while your body sinks deeper into stillness. And if you feel like it, you're invited to comment your location and local time, a small human signal sent out into the dark, or traveling much slower than light ever could. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. Without breaking stride, you continue forward, considering how strange it is that something so gentle could have a limit at all. The speed of light feels like a contradiction. Speed implies urgency, motion, maybe even stress, while light itself feels calm, ambient, almost lazy. Yet modern physics tells you that light in a vacuum travels at about 299,792 kilometers per second, a number so specific it feels like the universe showing off its precision. This value isn't just measured, it's baked into how we define distance itself, which is quietly mind-bending if you linger on it too long. A quirky tidbit floats by to keep things interesting. For a long time, some people believed light might slow down at night or speed up during the day, as if it were influenced by human schedules or the sun's mood. It's a charming idea, like imagining light yawning before its morning shift. But experiments eventually disagreed. As you rest with these thoughts, you notice how assumptions shape reality. If light feels instant, then the universe feels tightly stitched together. Cause and effect seem neatly aligned. But once you allow light to have a speed, even a very fast one, tiny gaps open up between events. Historians still argue whether early philosophers truly believed light was instantaneous or whether they simply lacked the tools and the patience to imagine otherwise. You don't need to resolve that tonight. For now, you just sit with the glow itself, the way it brushes past you, always moving. Always arriving, never quite as immediate as it feels. And as your breathing slows, the idea settles in gently. Before you can understand how fast light goes, you first have to notice that it goes at all. You drift backward in time without any sudden motion, as if the past itself is moving slowly to meet you. The people here don't have equations or clocks that can split seconds into neat pieces. They have firelight, starlight, and the daily rhythm of sunrise and sunset. And so you notice how natural it feels for them to assume that light simply is, appearing wherever it's allowed, without delay. When a torch is lit, the flame is seen immediately. When the sun crests the horizon, the world brightens all at once. There's no obvious reason to suspect otherwise. In ancient Greece, thinkers quietly debated this question while walking shaded paths and stone courtyards. Some argued that vision worked because something streamed out from your eyes, touching objects like invisible fingers. Others believed light traveled from objects to you instead. A mainstream historical fact settles in here. Philosophers like Aristotle leaned toward the idea that light was not a moving thing at all, but a condition of space. More like warmth spreading than a projectile flying. If light wasn't moving, then asking how fast it moved didn't even make sense. You can feel the comfort in that idea. A universe where light is instantaneous is tidy, calm, and emotionally efficient. Nothing important is ever late. No signal arrives too slowly to matter. And in a world without precision instruments, that assumption holds up remarkably well. When even looking at distant mountains or clouds, the delay is far too small for human senses to notice. Light, for all practical purposes, behaves like magic. A quirky tidbit slips in beside you. Some ancient writers speculated that light might require a medium, something invisible filling space, and that darkness was simply that medium unactivated. It's not quite right, but it's imaginative in a way that feels cozy rather than wrong. You can almost picture darkness as a quiet lake, light as ripples moving across it. As centuries pass around you, scholars in the Islamic Golden Age and medieval Europe revisit the problem. They refine ideas about optics, reflection, and lenses, but still, the speed of light remains mostly untouched. It's not ignored out of laziness. It's ignored because there's no clear way to test it. And measuring something that seems instantaneous feels like trying to time a thought or weigh a whisper. Historians still argue whether early scientists avoided the question because they believed light had infinite speed, or because they simply had bigger, more practical problems to solve, like calendars, navigation, and staying alive through the winter. Either way, the assumption persists, settling into textbooks and traditions like dust on a shelf. You rest in this long stretch of human patience, noticing how knowledge doesn't always advance by leaps, but by waiting for the right question to become unavoidable. For thousands of years, light keeps its secret not by hiding, but by behaving too well, too fast to catch, too reliable to doubt. And as you breathe slowly, you realize something comforting. Misunderstanding isn't failure here. It's a natural pause, a quiet inhalation before curiosity finally exhales and asks very gently, "But what if light isn't instant after all?" You move forward into a world where curiosity starts to outweigh comfort, where people begin to suspect that even the most obedient parts of nature might have measurable limits. The air here feels a little sharper, filled with the soft clink of instruments and the scratch of ink on paper. You can sense the shift. Light is no longer just admired, it's questioned. And questioning, is the slow beginning of timing. You stand quietly beside early experimenters who are trying to measure the unmeasurable with tools that feel charmingly inadequate. Pendulum clocks sway with solemn confidence, water drips in careful intervals, and in human reaction time, unreliable but all they have, becomes part of the experiment whether they like it or not. A mainstream scientific fact anchors this moment. By the 17th century, scientists were developing increasingly precise timekeeping devices, which made it possible to even imagine measuring something as fast as light. One method you notice involves distance. If light has a speed, then maybe sending it far enough will make its delay noticeable. It's a simple idea, almost obvious in hindsight, but deeply frustrating in practice. Earth is small. Hills are close. Even across valleys, light still arrives too quickly to betray itself. You can feel the impatience in these attempts, the quiet disappointment when results come back inconclusive again and again. And a quirky tidbit drifts past like a half-forgotten rumor. Some thinkers briefly wondered if light might move faster when it's brighter, as if intensity could push it along, the way shouting feels faster than whispering. It's a very human mistake, blending sensation with measurement, but it lingers for a while before fading under scrutiny. Historians still argue whether these early failures discouraged researchers from the problem, or whether they secretly confirmed something important, that if light had a speed, it had to be unimaginably high. Either conclusion is unsettling in its own way. Infinite speed feels philosophically heavy. Extremely fast speed feels practically unreachable. You watch as ideas compete gently rather than violently. Some propose that light speed could be finite but constant. Others imagine it might depend on the observer or the environment. There's no consensus yet, just a growing sense that the question itself is finally sharp enough to cut. As your breathing slows, you notice the beauty in these almost successes. No one gets the number right here, no one even gets close, but they do something more important. They prove that the universe is allowed to be timed, that even something as delicate as light can, in principle, be chased with patience and cleverness. You linger in this moment of near discovery, where failure doesn't feel like an end, but like a dim outline of what's coming. Light still outruns everyone, but now it leaves footprints, tiny conceptual ones, hinting that it's moving, not magically appearing. And once that idea takes hold, you sense that the next attempt won't stay on the ground for long. You find yourself standing on a quiet hillside at dusk, the air cool and still, the kind of evening where sounds travel farther than expected. Two lanterns glow faintly against the dark, separated by a long stretch of uneven ground. This is where impatience finally turns into action, where someone decides to test light directly, even if the tools are imperfect and the odds are not great. You're beside Galileo now, or at least beside the idea that bears his name. The plan is almost charming in its simplicity. One person uncovers a lantern. When the other person sees it, they uncover theirs in response. The first person times the delay. When a mainstream historical fact settles in here, Galileo Galilei was among the first to seriously propose an experiment to measure the speed of light on Earth, using human observers and shuttered lanterns across a distance. You already sense the problem before it unfolds. Human reaction time is slow, clumsy, full of hesitation and anticipation. The moment you see light, your brain pauses, confirms, decides, and only then tells your hand to move. That pause is enormous compared to whatever delay light itself might introduce. The experiment is doomed, but beautifully so. They try anyway, again and again. The lantern opens. The answering glow returns almost instantly. Too fast, always too fast. Galileo concludes not that light is infinite in speed, but that if it has a speed, it is far greater than what his method can detect. And that distinction matters. It's the difference between giving up and leaving the door open. A quirky tidbit wanders in here. Some later retellings exaggerate the experiment, placing it across miles or even mountaintops, as if distance alone could rescue it. In reality, no amount of hill climbing could outrun the limits of human nerves. Light wasn't just fast, it was faster than biology. Historians still argue whether Galileo himself truly believed the experiment could succeed, or whether he already suspected its failure and used it mainly to frame the question more sharply for those who would come after. Either way, the outcome is quietly profound. For the first time, someone has tried and failed in a way that teaches something specific. You rest with that thought. Failure here doesn't feel embarrassing, it feels instructional. When the universe has gently pushed back, saying not no, but not yet. Light remains untimed, but no longer untouched. As the lanterns dim and the hillside returns to darkness, you feel a subtle shift. The problem is no longer about clever tricks or faster hands. It's about scale, about distances so vast and clocks so patient that human reflexes no longer matter. You can almost feel the gaze lifting upward, away from hills and valleys, toward the sky. And as your breathing evens out, you carry forward a comforting realization. Sometimes the most important experiments are the ones that tell you exactly why they can't work. Light has won this round, but it has also revealed its weakness. It can't hide forever, especially not among the stars. You lift your eyes slowly, almost reluctantly, away from the hillside and into the night sky, one where distance finally becomes large enough to matter. Here, light has room to reveal its habits. Stars don't rush, they wait. Planets drift with quiet patience, and somewhere in that steady motion, you begin to notice something slightly off, like a metronome that occasionally skips a beat. You're now watching the moons of Jupiter, tiny points of light orbiting with dependable regularity. A mainstream scientific fact eases into place. In the 1670s, astronomer Ole Rømer studied the eclipses of Jupiter's moon Io and noticed that their timing shifted depending on Earth's position in its orbit. When Earth moved farther away from Jupiter, the eclipses appeared late. When Earth moved closer, they appeared early. The moon wasn't changing its behavior. The light was. You can feel the quiet thrill of that realization. And this isn't a lantern on a hill anymore. This is the solar system acting as a laboratory, distances measured in hundreds of millions of kilometers. The delays are small, minutes at most, but unmistakable. Light, it turns out, takes time to cross space, even cosmic space. Reamer doesn't calculate the exact speed as you know it today, but he does something more important. He proves that light is not instantaneous. It arrives late when it has farther to go. That single insight gently cracks open centuries of assumption, and the universe exhales as if it's been waiting for someone to notice. A quirky tidbit floats by here. Some contemporaries doubted Roemer's conclusion, suggesting instead that Jupiter's moons might be misbehaving, speeding up and slowing down out of spite or cosmic whim. Then it's a reminder that new ideas don't replace old ones cleanly. They overlap, argue, and linger awkwardly for a while. Historians still argue whether Roemer himself fully grasped the magnitude of what he'd found, or whether he simply reported the pattern and let others wrestle with its meaning. Either way, the pattern held. Repeated observations confirmed it. Light had been caught, not stopped, not slowed, but finally seen in motion. You sit with this moment, feeling how gentle the discovery is. No explosion of insight, no dramatic announcement, just a quiet mismatch between prediction and observation that refuses to go away. In science, that's often how truth arrives, softly, persistently, asking to be acknowledged. As your breathing deepens, you notice how comforting this scale feels. Like problems that are impossible on Earth become solvable when you let the universe help. Jupiter doesn't mind participating. Its moons keep their schedule. Light keeps its pace. And you, resting here, begin to sense that the number itself, the speed, will come soon. Not as a guess, not as a rumor, but as something earned slowly across the vast, patient dark. You remain with the stars a little longer, letting the idea settle that light can be late. That lateness, small as it is, opens the door to numbers, and numbers invite precision. This is where patience pays off, where observation turns into measurement, and where light, at last, begins to carry a price tag in kilometers and seconds. You drift into the 18th and 19th centuries, where instruments grow steadier and confidence grows with them. And a mainstream scientific fact anchors this moment. Experiments by scientists like James Bradley, who observed stellar aberration, and later Armand Fizeau and Léon Foucault, who used rotating wheels and mirrors, produced increasingly accurate measurements of light speed on Earth. Each method is different, but the result keeps coming back nearly the same, like a familiar refrain. You picture Fizeau's toothed wheel spinning in the dark, light slipping through a gap, racing to a distant mirror, and trying to return before the next tooth blocks its path. It's mechanical, almost industrial, and somehow elegant. For the first time, light is timed without human reaction, without guessing. Just gears, mirrors, and persistence. Now a quirky tidbit sneaks in. There was a brief period when scientists argued over whose method was more honest, as if light cared whether it was timed by spinning metal or dancing reflections. Pride, it turns out, travels much slower than light, but it still shows up everywhere. As the measurements sharpen, a number begins to solidify. Roughly 300,000 kilometers per second in a vacuum. Close enough that repeated experiments start to feel less like discovery and more like confirmation. Light isn't just fast, it's reliably fast. Historians still argue whether the scientific community accepted this value because it was correct, or because it finally fit neatly into emerging theories that needed a constant speed to function. It's probably both. Science, like sleep, often arrives when the conditions are just right. And you rest with the realization that this number isn't just a curiosity, it's foundational. Eventually, the meter itself is defined using the speed of light, flipping the old relationship on its head. Distance no longer measures speed. Speed defines distance. That's not just clever, it's quietly radical. As your body sinks further into stillness, you notice how calming that consistency feels. A universe where at least one thing always behaves the same way, no matter who measures it, no matter when. Light becomes a kind of cosmic metronome, ticking steadily beneath everything else. And with that steady tick in the background, you sense a deeper question forming. If light speed is always the same, then what does that say about motion, about time, about you? The number is in place now, solid, unmoving, and soon, and it's going to start bending things around it. You carry the number with you now, that steady 300,000 kilometers per second, like a smooth stone in your pocket. It feels reassuring at first. Constants usually do. They promise stability. But as you settle into the deeper implications, you begin to notice that this one doesn't just sit quietly. It rearranges the room. You enter a time when physicists realize that the speed of light isn't merely fast, it's special. A mainstream scientific fact unfolds gently here. Experiments like the Michelson-Morley experiment failed to detect any change in the speed of light due to Earth's motion, suggesting that light speed is the same for all observers, regardless of how they're moving. This result is strange enough to feel like a typo in the universe. If you're moving toward a beam of light, well, you'd expect it to meet you sooner. If you're moving away, later. That's how everything else works. Balls, sound waves, even rumors. But light refuses to play along. It arrives at the same speed no matter what, like a guest who ignores the traffic and shows up precisely on time. A quirky tidbit drifts in. Before accepting this, some scientists proposed that Earth dragged a mysterious substance called the luminiferous ether along with it, slowing or speeding light as needed. The ether was invisible, undetectable, and deeply convenient. It also didn't exist. Historians still argue whether the collapse of the ether theory was more shocking to physicists' intuitions or to their egos. Letting go of an invisible crutch is harder than it sounds. You feel the shift as Albert Einstein steps into this landscape, not with new experiments, but with a willingness to believe what the experiments were already saying. Light speed isn't just constant, it's the same for everyone. From that single quiet assumption, everything else begins to tilt. Time can no longer be universal. Space can no longer be absolute. Events that feel simultaneous to you might not be simultaneous to someone else. None of this feels violent or chaotic. It's more like furniture slowly rearranging itself when you're not looking. As you breathe, you notice how gentle the idea really is. Nothing breaks, nothing explodes. The universe simply chooses consistency over comfort. Light keeps its pace and the rest of reality adapts. You rest here, balanced between intuition and truth, feeling the soft strangeness of a cosmos that values one speed above all others. And as your thoughts slow, you sense that the consequences are only beginning to unfold, not as drama, but as quiet, unavoidable adjustments to how time itself must behave. You don't rush into the consequences. There's no need. Time itself, you're learning, prefers to be approached slowly. With the speed of light holding steady, something subtle happens to the ticking of clocks. Not all at once, not loudly, but enough that careful observers begin to notice the mismatch. A mainstream scientific fact settles in with a soft click. According to special relativity, time passes more slowly for objects moving at high speeds relative to a stationary observer, an effect known as time dilation. This isn't a metaphor or a trick of perception. It's been measured with atomic clocks on airplanes and satellites, which return ever so slightly out of sync. When you imagine two identical clocks, once perfectly aligned, one stays with you. The other takes a fast journey and comes back older by less time than expected. Not broken, not malfunctioning, just obedient to the rules light insists on. Time stretches to protect light speed, the way fabric stretches to avoid tearing. A quirky tidbit drifts in to keep things light. Early explanations compared time dilation to fatigue, as if fast-moving clocks were simply tired and needed more rest. It's a charming idea, and not entirely wrong in spirit, even if physics prefers sterner language. Historians still argue whether Einstein himself was more troubled by time dilation or delighted by it, since it solved more problems than it created. The papers don't say, the equations don't care. But you can imagine the quiet satisfaction of a universe that finally clicks into place. You feel this effect personally now, even if you've never noticed it. GPS systems must account for time dilation to work properly. Without adjusting for the way satellites experience time differently, your location would drift by kilometers each day. Light speed, once an abstract number, now helps you find a coffee shop without getting lost. As you settle deeper, you notice how non-threatening this strangeness feels. Time doesn't shatter, it softens. It becomes flexible, responsive, forgiving. There's no single cosmic clock barking orders. Each observer carries their own, ticking honestly according to where and how they move. You rest with the idea that your experience of now is local and personal. We shaped by motion and light rather than universal decree. It's oddly comforting. No one is late. Everyone is just moving through time at their own perfectly valid pace. And as your thoughts slow further, you sense that if time can bend this way, then space itself may not remain rigid for long. Light, patient, and unwavering continues to set the terms. You let your attention drift outward, from clocks to distances, from seconds to meters. If time can stretch to protect the speed of light, then space, you realize, must also learn to compromise. It's only fair. The universe prefers symmetry, even in its quiet revolutions. A mainstream scientific fact glides in smoothly. Objects moving at speeds close to the speed of light experience length contraction, meaning they are measured as shorter along the direction of motion by a stationary observer. This isn't an illusion. It's geometry responding politely to an unbreakable rule. You imagine a long spacecraft, sleek and calm, passing by at an incredible speed. To you, it looks slightly compressed, like a breath held in. To the people inside, everything feels normal. Floors are the right length. Hallways don't pinch. Reality hasn't betrayed anyone. It has simply agreed to disagree, depending on who's doing the measuring. A quirky tidbit wanders in here. Some early science fiction writers worried that length contraction might make high-speed travelers squished, like cosmic pancakes. Thankfully, physics spares everyone that indignity. Only measurements change, not experiences. Historians still argue whether length contraction was initially accepted because it was experimentally supported, or because it elegantly preserved the mathematical beauty of relativity. Either way, it stays. Like time dilation, it's been confirmed indirectly again and again, woven into particle accelerators and cosmic ray observations. You notice how calm this all feels when you stop resisting it. Space isn't collapsing, it's cooperating, adjusting itself so that light can remain constant, no matter who's watching. There's something almost kind about that, as if the universe values consistency more than rigid structure. As you breathe slowly, you reflect on how distance in everyday life feels so solid. A room is a room, a road is a road, but zoom out or speed up, and those certainties soften. Space becomes negotiable, flexible. I'm willing to change shape rather than break a rule. You carry this with you gently. The idea that the universe isn't brittle. It bends, stretches, and adapts. Light doesn't demand obedience loudly, it simply refuses to change, and everything else rearranges itself in response. And as your thoughts continue to slow, you sense that these cosmic rules aren't reserved for distant stars or theoretical travelers. They reach all the way down to you, to the everyday light that fills your room, quietly enforcing the same deep, patient laws. You return gently to the small, familiar lights around you, the kind you barely notice anymore. The glow of a phone screen dimmed for night mode, a lamp casting a soft circle on the wall, headlights sliding past like slow-moving comets. Ciara, it's comforting to realize that the same rules governing distant galaxies are quietly active right here, in the most ordinary moments of your life. A mainstream scientific fact settles in with reassuring weight. Every time you see something, you are seeing it as it was in the past, because light takes time to travel from objects to your eyes. The delay is tiny, nanoseconds across a room, but it's real. Even your own reflection in a mirror is slightly out of date, which is either fascinating or rude, depending on how tired you are. You let that sink in. There is no perfectly current view of reality. There is only what light has had time to deliver. The present, it turns out, is always a negotiated compromise between distance and speed. A quirky tidbit drifts by. Some neuroscientists joke that your brain is constantly editing reality. We're smoothing out these delays so you don't feel like the universe is lagging. You're essentially living in a carefully curated highlight reel, buffered just enough to feel seamless. Historians still argue whether early modern thinkers would have found this idea thrilling or deeply unsettling, that no observer ever experiences the true, simultaneous now. But you don't feel unsettled. Lying here, you feel oddly comforted. If everyone is slightly out of sync, then no one is truly behind. You notice how technology has learned to respect light's limits. Fiber optic cables route data at near light speeds. Satellites wait patiently for signals to arrive. Engineers don't fight the speed of light anymore, they design around it. Latency isn't a failure, it's a fact of existence. As your breathing evens out, when you sense how deeply light structures your daily rhythm, sunrise doesn't just illuminate, it tells your body what time it is. Screens glow warmer at night to mimic fading daylight. Even your sleep cycles are quietly choreographed by photons that left the sun 8 minutes ago. You rest with this connection between the cosmic and the mundane. The same speed limit that shapes space-time also decides how long it takes a text message to cross the ocean, or why a video call feels just a fraction delayed. Light keeps everyone honest, patient, and just a little bit forgiving. And as your thoughts grow heavier, you feel ready to wander into the stranger corners, those places where the speed of light seems challenged, bent, or misunderstood. Not because it fails, but because it's so often mistaken for something it isn't. And you slow your pace even more now, approaching the edge cases with care, like stepping onto thin ice that's been tested but still feels uncertain underfoot. This is where the speed of light gets misunderstood most often, not because it breaks, but because it's asked questions it was never meant to answer. A mainstream scientific fact arrives calmly. Nothing with mass can be accelerated to or beyond the speed of light in a vacuum. Doing so would require infinite energy, which is physics' polite way of saying, please stop asking. Light isn't fast because it's powerful. It's fast because it has no mass to weigh it down. You notice how often this rule gets bent in conversation. Headlines claim particles travel faster than light. Galaxies are said to flee the universe faster than light itself. It sounds rebellious, almost thrilling. But it's mostly a misunderstanding of terms. Space can expand faster than light without violating the rule because it's not things moving through space. It's space itself stretching, carrying galaxies along for the ride. A quirky tidbit drifts in here. In certain materials, light slows down enough that particles can outrun it locally, producing a bluish glow called Cherenkov radiation. It looks dramatic, like science fiction made real, but it doesn't break the cosmic speed limit. It just exploits the fine print. Historians still argue whether public confusion about faster-than-light ideas comes more from oversimplified science communication or from humanity's deep emotional desire to outrun limits. Probably both. Rules feel more tempting when they're clearly marked. One, you rest with the idea that light speed isn't about restriction. It's about structure. It sets the tempo so the universe doesn't unravel into contradictions. Cause stays ahead of effect. Messages arrive in order. Reality remains narratable, one event following another without looping back on itself. As your breathing slows further, you notice how gently physics handles its boundaries. There are no cosmic police sirens, just quiet impossibilities that never quite happen. You can imagine trying forever to push something faster and simply finding that effort turns into mass, heat, resistance, anything but extra speed. You linger here, in this calm acceptance of limits. The universe isn't teasing you with forbidden fruit. It's offering consistency instead. A dependable rhythm that allows stars to burn, atoms to hold together, yes, and stories to make sense from beginning to end. And with that reassurance settling in your chest, you feel ready to drift into the final thought. Not a debate or a paradox, but a quiet understanding of what it means to live in a world paced, patiently and forever, by light. You arrive without effort now, as if the journey has been carrying you rather than the other way around. The speed of light no longer feels like a fact you're holding in your mind. It feels like a background rhythm, something steady and patient that has been there the entire time, quietly keeping everything in step. A mainstream scientific fact settles in gently. The speed of light in a vacuum is a fundamental constant of nature, woven into equations that describe energy, mass, space, and time themselves. It's not just how fast light travels, it's how fast information can move, how quickly the universe can respond to itself. Every cause waits its turn behind that limit. You notice how comforting that is. Nothing rushes ahead of consequence. Nothing arrives before it's allowed to exist. Light sets the pace and reality follows, orderly and calm. A quirky tidbit drifts by like a final smile before sleep. If the speed of light were even slightly different, stars might not form properly, chemistry might fall apart, and you likely wouldn't be here listening at all. The universe, it seems, chose this speed not for drama, but for balance. Historians still argue whether humanity's fascination with light speed comes from scientific curiosity or from something more emotional, a desire to know the ultimate boundary, on the far edge of what's possible. Maybe limits feel meaningful because they define the space where everything else gets to happen. You don't need to solve that tonight. You simply rest in the idea that the universe isn't hurried. Even at its fastest, it moves with restraint. Light doesn't sprint recklessly. It glides, constant and unbothered, stitching moments together into something that feels like continuity. And now, without any sharp transition, the thoughts begin to thin out. The details soften. The numbers lose their edges. What remains is the feeling. That deep, steady reassurance that the world is paced, not chaotic, governed by rules that favor patience over surprise. Your breathing slows further. The glow of understanding fades into warmth rather than brightness. You don't need to hold on to the speed of light anymore. And it's holding you. You let the ideas drift away like distant headlights disappearing down a quiet road, growing dimmer, softer, until they're just suggestions rather than shapes. There's no need to follow them. They know where they're going. You feel the room around you again, not sharply, not urgently, just enough to notice the steady temperature of the air, the gentle weight of gravity doing its reliable work. Light continues to move, of course. It always will. But for you, right now, there's nothing it needs to reveal. Your thoughts stretch out, long and unhurried like shadows at sunset. There's no race to finish anything, no expectation to remember every detail. Understanding has already done its job. What's left is rest. You imagine light leaving distant stars, beginning journeys that will take years, centuries, one longer than any human lifetime. They're in no rush, neither are you. Everything arrives when it's meant to. The universe keeps its pace. Your breathing keeps its own. In this moment, they don't need to match. They simply coexist, steady and calm. And as sleep settles in, you don't fall into darkness. You drift into a softer kind of glow, one without speed, without measurement, just a quiet, comfortable pause.